now want to look at inequalities involving absolute values. And let's start with an example. There are actually two cases to this, and we need to consider each one. Let's start with the less than case. Something like absolute value of x is less than 3. This tells me that I need numbers that have an absolute value smaller than 3. 2 has an absolute value smaller than 3. So does 1 and 0, and -1 and -2, but we can see that we eventually have to stop because -3 has an absolute value equal to 3. The general rule for this case is that if the absolute value of u is less than a, then we actually set up a compound inequality. -a is less than u is less than a. And all of these less than symbols can also be replaced with a less than or equal to. On the other hand, if I consider something like the absolute value of x is bigger than 3, we could use numbers like 4, 5, 6, etc. They'll all have an absolute value bigger than 3. But so will -4 and -5 and -6, etc. In this case, if we have that the absolute value of u is bigger than a, we set up two inequalities. That u is bigger than a, or u is less than -a. And depending on if we have a less than or a greater than sign, it'll tell us which one of these two rules that we need to use. Let's start with 3x plus 5 is less than 12. We need to use the less than rule, which says to set up the compound inequality, -12 is less than 3x plus 5 is less than 12. We can then subtract 5 from all three sides. That gets me -17 is less than 3x is less than 7. Dividing all three sides by 3 gives me -17 over 3 is less than x is less than 7 over 3. Writing this in interval notation, we use parentheses since we do not include either one of our endpoints. For the absolute value of 2x minus 4 is greater than or equal to 3, I now need to use my greater than rule. It says we set up 2x minus 4 is greater than or equal to 3, or 2x minus 4 is less than or equal to -3. On the left, we can add 4 to both sides. That gets me 2x is greater than or equal to 7. Dividing both sides by 2 gives me x is greater than or equal to 7 over 2. For my second equation, I add 4 to get 2x is less than or equal to 1. Divide by 2 to get x is less than or equal to 1/2. If we want to write this in interval notation, this first equation says that x is bigger than 7 over 2. So 7 over 2 to infinity. And we use a square bracket to include 7 over 2. The one on the right says that x is smaller than 1/2. So we need numbers that are smaller than 1/2. And we use this square bracket to indicate that we include 1/2. In the center, we have this mathematical symbol that looks like a U. This stands for union, and it means combine these two. Next, let's look at 7x minus 4 is less than or equal to 9. We need our less than rule again. That says -9 is less than or equal to 7x minus 4 is less than or equal to 9. I can add 4 to all three sides. That gets me -5 is less than or equal to 7x is less than or equal to 13. We divide all three sides by 7 to get -5 over 7 is less than or equal to x is less than or equal to 13 over 7. So the smallest it can be is -5 over 7, and the biggest is 13 over 7. And we use square brackets to indicate that we are allowed to include the endpoints. Let's look at one more. This is a greater than problem, so we need our greater than rule. That rule said 4x plus 7 is greater than 8, or 4x plus 7 is less than negative 8. For my first equation, I can subtract 7 from both sides to get 4x is greater than 1, and divide by 4 to get x is greater than 1/4. In interval notation, I know it needs to be bigger than 1/4, so 1/4 to infinity, and we use parentheses since we do not include the 1/4 point. For my other one, I can subtract 7 to get 4x is less than negative 15, and then divide by 4 to get that x is less than negative 15/4. So it's smaller than this, so it's going to go from negative infinity to negative 15/4. Once again, we use this U symbol, which stands for union, to indicate that we want one or the other.